Okay, thank you all for having me here in your NIHA forum. Thank you to Dr. McClure for getting me involved with you so that I can fill you with 5 hours full of mercury science. Just to let you know where I come from in all this, I actually came from an environmental chemistry background. I got a PhD in environmental mercury chemistry, and the academic lineage I came from did a lot of work speciating mercury, which is separating different forms of mercury, and part of speciation is also predicting and modeling what things mercury and other heavy metals will be bound to in the environment and in biological systems. And I used that knowledge to develop testing methodologies for separating different forms of mercury in people so that we can look at fish-based and amalgam-based mercury separately. We can also, if we want to, look at vaccine-based mercury. And from there, I started my own company based on the technology we developed. I patented it in graduate school. And I started this company, Quicksilver Scientific. And from that original roots in environmental and industrial work, I moved into doing clinical work and started working on detoxification. I'd always had a lot of interest in natural healing. In fact, I used to be an organic farmer before I got my PhD in chemistry, and so I had a lot of background in natural health. And I applied the testing to the clinical world and, as I said, to detoxification work. So I just wanted to show you the website, because if you go to our website and go into it and log in, first you have to register. In the clinical side, if you register, you can get into where all of the information is. And so you would register, and you'll get a username and a password, and from there you'll be able to get into where all of our protocols, actually I don't remember my password. You can get into where all of our protocols and monographs about products, about testing. There will be slides like the slides that we're going through now. There's some PowerPoints, there's some videos. We're going to keep populating this with videos, with webinars, and so everything that we go through now, you'll be able to go back and refresh on by going to the website. And this is a members-only section of the website. So we're doing this in 5 sections, and loosely those 5 sections are talking about the key forms of mercury that we're exposed to and the exposure routes, how the natural detox system works, how the natural detoxification system gets altered, leading to biochemical stress. Then we're going to talk about mercury speciation testing for diagnosis and monitoring of treatment. This testing is all without provocation. This is all ambient tests, blood, hair, and urine. You can look at the different forms of mercury in the body and how well your body is working with those forms. And then we'll look at our detox system, the intestinal metal detox system, to repair and amplify the body's natural detox system for safe mercury and heavy metal removal. So now I'm going to just review a little bit of what I went over before. I jumped pretty heavily into the detoxification system, and I just want to run through a little bit of that and then go into the testing that we use. So I had presented this idea of the antioxidant detoxification protein repair system, this being a system of what we think of as antioxidants, and their use through the body being dictated by these systems of different enzymes. And these enzymes bring those antioxidants, such as glutathione, into antioxidant functions, like glutathione peroxidase using that. Once that is used up and oxidized, glutathione reductase brings it back into the glutathione pool. You can use glutathione for protein oxidative repair through glutaredoxin. And then once that's oxidized, again, it's brought back into the central glutathione pool by glutathione reductase. You can use glutathione for detoxification by linking it to toxins using glutathione as transferase, after which you have a series of transmembrane transporters which shuttle it out of the body. These are multi-drug resistance proteins and organic anion transport peptides. And there are other things like thyrodoxin, lipoic acid, vitamin C and E and A, CoQ10, that all have their respective enzymes for pulling them into different aspects of the body system. And so it's not, people usually think in terms of quantities of these antioxidants, but it's really more important that you have the enzyme system properly working. I believe now, I don't remember exactly where we stopped, unfortunately, so I'm going to run through these quickly. We talked, I believe, about the detoxification phases. Phases 1 being the oxidative activation of a toxin, phase 2 being conjugation or mobilization, and phase 3 being transport out of the body. How the phase 1 is associated with the P450 system, which is really creating a free radical out of a toxin. It's not needed for metals, but for something like estrogen or a PCB or a PAH, you need to create a free radical out of it so that you can move it into phase 2 conjugation, so then it can be worked on by the phase 3 transport proteins. So since you're creating free radicals, you have to have these things tightly coupled to phase 2. I think I mentioned before that there's work done at Johns Hopkins looking at how free radicals of estrogen are causative mechanisms for the formation of breast cancer and probably prostate cancer as well. Phase 2 conjugation makes the toxin water soluble and recognizable by transporters. Glutathione as transferase is our main character for mercury, and we've seen low expression of this in people with high methylmercury and sensitivity to thimerosal. The sensitivity to thimerosal was happening in the medical world, where they're using thimerosal for a number of different antimicrobial reasons. Phase 3 is then the transport out of the body. Several transport proteins involved in this: the organic anion transport proteins, the multi-drug resistance proteins, and these originally were called glutathione S conjugate transporters. Now, these are all organic anion transporters, which is important in terms of us, in terms of all of these conjugates being anions. And that's one of the ways that they're recognized, and they're recognized more specifically than just anions. And more important than anything is that even though for glucuronidation, sulfation, glycation, or glycination and glutathione conjugation, there's a different enzyme for every one of these things. There's different phase 1 enzymes for different aspects of that part of the pathway. But there's only one transport system for getting out of the body. So when you block up this transport protein, you're not just blocking up the glutathione pathway, you're blocking up all of these pathways. So recognizing phase 1 limitations is more important than, recognizing phase 3 limitations or blockages at phase 3 is more important than individual enzyme pathways from phase 2, because it's a more broad spread effect. And incidentally, just like we have gene panels now for glutathione as transferase genes, I just returned from the Global Mercury Conference at Halifax, Nova Scotia. Every 2 to 3 years, all the mercury guys from around the world get together and present their findings. And I've been looking for MRP2 gene SNPs to measure, and sure enough, there's a group from Sweden that's doing this now, and we're going to work on developing these panels out, and we're going to look at some testing that we've done on dentists and see how well the MRP2 gene SNPs work into this. They've been working on artisanal miners who were exposed to gargantuan amounts of mercury. This was something to put things in perspective. These people were looking at levels hundreds to thousands of times higher than we're typically looking at. They were also looking at symptomology that was more Minamata disease level, really drastic blowout of the nervous system. But they were finding that the people with stronger MRP2, stronger transport systems, had lower levels of mercury in the body and less toxicity. So this is our schematic of a healthy detoxification system. Up in the cell, anything in the upper regions is in the cell. You've got phase 1 moving into phase 2. So activation moving into conjugation, those conjugates moving into phase 3 at the cellular level, being kicked from the cell into the blood. You've got another phase 3 brother of this one, pulling it from the blood into the liver. Then you've got another one kicking it from the liver through the bile duct into the small intestine. Now you do have these MRP2s along the whole small intestine where they can draw straight from the blood, though this is the dominant pathway. These things are also located in the kidney, but this is really the dominant path out. So then the question is, how does the natural detox system get altered, leading to biochemical stress? You can have deficiencies, you can have glutathione deficiencies, and these can be genetic polymorphisms, what we call SNPs, or this can be epigenetic dysfunction. And there's an important thing to recognize in a lot of the gene testing that we do, that we're not really sure whether when we amplify out through PCR to look at GSDM1 in a Genova panel, we're not sure that that gene is missing or that that gene is epigenetically switched off and we just can't amplify it. So either of these two things can be there. And then there can be environmental problems where you've got oxidative consumption of your glutathione pool that's drawing it down, or strong inflammatory processes. And that's one of the take-home messages in this whole series here, is that you've basically got two modes of being. You've got detoxification or you've got inflammation. And when one goes up, the other one goes down. Inflammation is essentially an oxidative situation where you're supposed to be temporarily going in and creating oxidative activity to wall off an infection or to try to repair something. And then when that's done, you go back in with your house cleaning proteins, which is all those detoxification enzymes I mentioned before, used to be called house cleaning proteins. Then they come back in and clean house. When you get stuck in chronic inflammation, now we all know that story. We all know that temporary inflammation is natural, chronic inflammation is bad, but once you couple that into the fact that the chronic inflammation downregulates the detoxification system, now you start to understand the real ramifications of chronic inflammation, and the ways that they can create a lot of damage is by letting a lot of toxicity through. Once you couple that to knowledge that's just emerging so strongly now of the damaging effects of metals on the cardiovasculature, now you see that inflammation has a real direct way to work on the vasculature, and that's by creating damage on the epithelia of the vasculature. And that's because the inflammation is letting more metals run around through your system. Then glutathione S transferase, that's the phase 2. You've got the same scenario. You've got genetic or environmental inflammatory mechanisms for breaking that system down or slowing that down. And remember all the other toxins that are handled by the glutathione system. You've got aflatoxins or mold toxins. You guys are out there on the wet East Coast, and I'm sure you've got plenty of wetness. Recently, I was just in New Jersey and got delayed coming back out here, so I just got back last night due to all the rain there. And you'll see a lot of mold toxicity. And by show of hands, which is going to do me no good over the webinar, raise your hand if you've seen chronic mold toxicity and chronic mercury toxicity together. The reason you see those co-located in an individual is because it's the glutathione system that's responsible for cleaning up mercury and responsible for cleaning up glutathione. So when that's down, you will be susceptible to both of those toxins. Fluorinated hydrocarbons, we don't see as much. We've eliminated them from dry cleaning. We've eliminated DDT. But what do we find when we look at who was getting sick during DDT? It was kids with problems in the glutathione system. Other things, organic nitrates, paracetamol, radiation. Radiation produces reactive oxygen species, and so you need a healthy glutathione system and a healthy bank or reservoir of reduced thiols in the cell. When we talked about the glutaredoxin system, we talked about how the bank of cellular thiols, of which there is much more than there is free glutathione. That bank of cellular thiols can be used as a warehouse of antioxidant activity and then has to be repaired with glutaredoxin. So you need a nice, healthy level of reduced sulfide or reduced sulfhydryl groups, and then you need enzymes to broker all of these monetary exchanges of electrons. The gene story with glutathione genes and illnesses is always coming down to glutathione transferase genes, but now that we're looking at these phase 3 genes, I bet we're going to see even more stronger relationships with chronic disease. You go to PubMed and you search glutathione and cancer, you're going to see no relationship at all. But if you search glutathione transferase in cancer, you're going to see all of these studies linking different cancers, leukemia, cancers of the cervix, prostate, head, neck, lung, to glutathione transferase issues, cirrhosis of the liver, type 2 diabetes, schizophrenia. These are going to be linked more to glutathione transferase genes than to glutathione itself. And it's not just going to be whether you have the transferase problem, but you need the transferase problem plus exposure. So looking at bladder cancer, you've got a 1.7 time increase in bladder cancer with SNPs of GSTM1 or T1, but then if you couple that to exposure, that odds ratio goes up. Some of these papers on odds ratios of cancer go up as high as 15-fold when you're coupling exposure and transferase problems. And so when we looked in the beginning at this slide from the Iraq poisoning, we saw that there are fast in the biological half-life versus frequency of the population. There's fast detoxifiers and there's slow detoxifiers, and then there's ultra slow detoxifiers, this 10 to 12% group over here. That's consistent with what a lot of other people are talking about in terms of genetic profiling of groups that are slow detoxifiers. When you talk to hear Richie Shoemaker talk, he might be looking at different genes, but he's finding this same sort of grouping. Glutathione enzyme and glutathione levels in aging populations. This study that was done on rats. You've got young rats and old rats, and you see for glutathione in the liver and the kidney, vitamin C and vitamin E in the liver and the kidney, you see an 18 to 37% decline just with aging. Now, we'll see when we talk about the treatment system and the use of this particular plant extract. This plant extract was able to completely correct this age-based deficiency. But you see, just that alone, and what else do we have with age is chronic inflammation. You see this bank, this reservoir of antioxidative activity is declining with age. When we look at the enzymes involved in the super system, we see the enzymes are faring even worse than the base antioxidants are. Manganese superoxide dismutase, glutathione reductase, glutathione transferase, G6-PDH, all of them going between 35 and 50% declines just by age. And then there's one thing that we see that reverses that pattern. That's an increase in catalase, glutathione peroxidase. Now, why would that be? That would be because this whole reservoir of antioxidant activity is going down. You've got more free radical reactions breaking out of their sites of activity and being able to create oxidative damage, lipid peroxidation, hydroperoxyl radical formation, and thus, instead of cleaning things up on the front end by having a robust antioxidant system, you end up putting your energy into the fire extinguishers, catalase glutathione peroxidase, and having to clean up the damage that's been caused because your defenses were low. Now, I said that this particular polyphenolic extract, this one is from Haritaki. It's an Ayurvedic herbal extract. When they treated these rats with the Haritaki, all of these numbers went up and these numbers went down. So their antioxidant pool was restored, their antioxidant enzyme pool was restored, and they no longer had to put a disproportionate amount of energy into the fire extinguishers. These concepts are all very important when we look at our treatment plans. When you look at what we want to do with treatment, everybody's known that these adjunctive treatments, even if you're going to do IV chelation therapy, bringing up the antioxidant pool has always been important. Bringing up the sulfur pool has always been important. And now we understand why that's important. So we said glutathione and glutathionase transferase have genetic and environmental components. Now we're finding genetic and environmental components for phase 3, but until I found the phase 3 genetic ones, I was left with mostly the environmental reasons for phase 3 blocking. And remember, when we blocked phase 3, we blocked multiple pathways. And what's the biggest reason for phase 3 dysfunction? Inflammation, especially in the gut. We mentioned that autism, this is a hallmark of autism cases. You've got inflammation in the gut, you've got toxicity in the body, and you've got a lack of detoxification, and you're under this chronic oxidative stress. So we take that normal picture, we downregulate these transport proteins, negative inhibition on phase 2, buildup of cellular and blood-borne toxins, so we're not able to move things out, but nobody informs phase 1. I hypothesize that phase 1 comes from different evolutionary backgrounds from bacteria. Phase 2 and 3 are better co-regulated, and so you end up with generation of free radicals inside the cell with nowhere for them to go. The work at Johns Hopkins on estrogen found that they've got estrogen free radical generation here, no coupling to glutathione, no coupling to glucuronic acid, no movement out of the cell, and these women end up peeing out mercury or DNA estrogen adducts that are formed by the estrogen free radicals. They're creating the mutations at the cellular level, leading to the cancer generation. And they corrected that just by upregulating phase 3 using known phase 2, upregulating phase 2 using phase 2 upregulating compounds. The concept then of dental amalgam poisoning the gut, creating local chronic inflammation in the intestines, that leading us into this scenario and blocking all of that movement out of the body. We'll look later on at a study that was done in Germany where they removed the amalgams and then tracked both methyl and inorganic mercury in the blood over a 2-year period and had a really interesting results that support this whole notion of removing this blockage here and upregulating these phases of detoxification just through the amalgam removal. They didn't know what their data meant actually, but we do. Then a look at, this is a look at rinsing the mouth with N-acetylcysteine and how much mercury is stored in the oral cavity. And there's a little bit of communication with the blood in the mouth. And this is a rinse. This is methyl mercury and inorganic mercury coming out of our detector of somebody without dental amalgams. This is another person without dental amalgams. These are low amounts of mercury. Then someone with dental amalgams, you rinse your mouth with N-acetylcysteine, spit that out, and we analyze the rinsate, and we see this phenomenal amount of inorganic mercury, 2,000 times more than a person without dental amalgams. You rinse them again, you get even more. There's a huge reservoir of inorganic mercury that's in the oral cavity, and that means that's rinsing through the whole intestine. Just to show you all this again, because it was a lot, and I'm going to run through it quickly, but this was the establishment. This was creating inflammation in the body through injections of endotoxin, endotoxin being a lipopolysaccharide. I don't think the authors were so aware of what this study really means, but endotoxin or lipopolysaccharide is what we're translocating into the body through chronic infectious foci, such as cavitations, root canals, and what we're bringing into the gut through leaky gut, or what we're bringing into the body from the gut when we have leaky gut. And when they injected this into the body, they created an inflammatory response in the body, and they were able to measure inflammation through upregulation of IL-6, which is an inflammatory cytokine, and they find this strong turning up of inflammation where? In the intestine. Here we have the duodenum, jejunum, ileum, all inflamed from an injection into the muscle. Here we have inflammation. Oh no, I'm sorry, this is downregulation as a result of the inflammation, downregulation of the detoxification enzyme system. This is MDR1A. This is an overarching detoxification gene. And where does that turn down? Turns down all through, globally through the intestine. So the intestine is inflaming and turning down its detoxification activity. We see now specific different enzymes in the liver being all turned down except one protein. This is the MRP3. This is a transport protein that goes from the hepatocyte back into the liver. This particular pathway is for taking things from the hepatocyte out to the cell to go to the kidneys, because they were not able to go through MRP2, which we see strongly downregulated. That's the one to the gut. So we see the path to the gut blocked and the path out to the kidney being relied upon. This is just more looks at how strongly the transport proteins were turned down. Some of them turned down as far as 75% downregulation of the activity of the transport proteins. So now, instead of going from our gut, we are now shunting a lot of that detoxification load over to the kidneys, overloading the kidneys. The kidneys can cope with this for short periods. Remember, when inflammation happens, this is supposed to be short periods. So this tells us also when we're in inflammation, we should support the kidneys. But once we've done that for too long, we've shunted to the kidneys for too long, we blow out the kidneys. So now we've got a blowout in the intestinal path and the liver and the kidney urinary path. And remember that a lot of the old naturopathic indications for kidney problems, they said better look to the gut. There probably is a gut problem there. So whether the inflammation is from parasitic infection or chronic irritation from dental amalgam, or both, realize that you're affecting the kidney when you're infecting the gut. We've also got reabsorption in the gut called enterohepatic circulation. For methylmercury, this can be 90% or even higher, where you take methylmercury as a glutathione conjugate out into the bile. It's broken back down in the intestines to methylmercury cysteine, which was the original form you absorbed when you ate the fish, and then you reabsorb it. Eventually it's found by your detox system, conjugated to glutathione, and this cycle repeats itself. All right, so now we'll move into talking about testing. Testing for mercury has ambient measures for testing, and it has provoked measures. In the ambient measures, we've got blood, hair, urine, and stool. In the provoked measures, we've got urine. Now, sure, there are some stool provocations, but they're less widely used. The way that we do things, it would seem like we would use stool provocations, but I find that highly variable, so we don't use them. So if we just keep it to this system, we've got ambient measures, and what are in those ambient measures? In blood, we've got methyl and inorganic mercury. Of those two, typically methylmercury is the larger one. If you're exposed to both fish and dental amalgam, methylmercury will swamp out inorganic mercury. When I show you the normal ratios, when I show you the reference ranges we've developed, the reference ranges for methylmercury just say the 95th percentile for methylmercury is about 15 times higher than the 95th percentile for inorganic mercury. That is not because you have 15 times more methylmercury. It is because the methylmercury becomes more highly associated with the blood than the inorganic mercury. Both of those forms are much more pushed in their distribution towards being bound to cellular proteins than being bound to blood proteins. But of the two, methylmercury tilts itself towards the blood more. This is true throughout all of the environmental compartments as well as throughout your body. So if I dumped equal amounts of methyl and inorganic mercury into you, once they settled in your body, methylmercury would be 10 to 15 times higher in the blood. This is one of the reasons that blood was always a confusing measure and was never able to be really nicely correlated with how many amalgams people had or what their toxic symptoms were like. But once we're able to separate these two, put them in their own reference ranges, they become very, very valuable measurements. And looking at the ratio between these two becomes a very instructive measurement. But back to what's in blood. Blood has methyl and inorganic mercury. Hair is methylmercury only. Most of you know this, but I know a lot of naturopaths will use hair as a measurement of dental toxicity, and it absolutely cannot be used for that if you're just looking at the mercury levels, because if this person eats no fish at all, they will come back with low hair mercury. There's no way around that. If they eat a lot of fish and have no amalgams, they'll come back with high hair mercury. Urine is only inorganic mercury. There's a little bit of methylmercury, but it is really just inorganic mercury. And so that was never able to be correlated very nicely with blood. Now, when you're looking at these artisanal miners who are artisanal miners are using liquid mercury, panning sediments for elemental gold and amalgamating it with mercury, and then they burn the mercury off, and so they're exposed to gargantuan amounts of elemental mercury. In this case, where elemental mercury turning to inorganic mercury is dominating the system, there is nice correlation between blood and urine because they're swamping out all of this methylmercury signal. But in most people in the first world, you need to separate these two to make these things make sense. Stool is both methylmercury and inorganic mercury, but there's a lot of interconversion of these two pathways in the stool, and the stool levels are going up and down very quickly, or quite a bit through the day. Provoked urine then has methyl and inorganic mercury. Instead of just inorganic mercury, you're shunting both methylmercury and higher amounts of inorganic mercury through the urine. So the old dictum with blood, and I'm sure all of you have heard this before, is that blood is only recent exposure. Only the last 2 to 3 days, people will say. That's all that's in there. And this really is not true at all. And oftentimes in science, and especially in clinical work, what's laid down at one point by somebody is often perpetuated for quite a bit of time, even though the evolution of the science is showing us different things. And so in the case here, that 3-day residence time was only a quick peak and decay after a large dose. What happens is when you take in a bolus dose of, say, fish, say you go out and eat swordfish steak, Your blood peaks within 12 hours and then over the next 3 days distributes through the body. But after those 3 days, you're at a much higher level in the blood than you were in the beginning. So you've got a baseline measurement before the bolus dose, then you've got a peak and decay down to another baseline. So you've got a rapid decay, then you have a very slow decay after that, going back down to baseline. And I'll show you data. This is not 3 days. This is more like a half a year or more. So for methylmercury, you're developing a steady state after the initial decay. And I'll show you some data where for methylmercury, the blood to organ ratio is very, very nice, a very linear correlation. Because of its kinetics of movement between compartments, it's an excellent predictor of what's in the compartments. Inorganic mercury has much slower kinetics of movement through compartments, so it is a good indicator of loads to the compartments while it's being loaded in. When it's coming out, it loses its coupling a little bit, but it still is a very nice measurement. So blood does have very nice correlations with body burden. Now the real problem, the reason people never understood this, or well, they didn't in the 70s when they started talking about blood being a 3-day exposure. The real problem is the detection limits weren't high enough to see these dynamics, and there was no speciation to see these dynamics very accurately. You need very sensitive equipment. So when we look at this, this time-based correlation, this is a look at blood methylmercury before and after eating tuna fish. And so one of my technicians ate 2 cans of tuna fish. We measured his blood at time 0. 2 hours later, he's gone up about from 0.4 to about 0.9. So he's gone up over 2-fold. Then 24 hours later, he's up to about 2.4, so he's 6-fold higher. We didn't know at the time that the peak was in the middle of the night at 12 hours, and so he was probably up here somewhere. And then a couple of days later, he's back down quite a bit. Now, years ago when they looked at this stuff originally, this was the detection limit of the instrument. Detection limit is very important when you are evaluating data from a lab and it says less than a number. That does not mean 0. So they were running around 1.25 to 1.5, sometimes 1. If it says less than 1.25, that does not mean 0. It means they don't know what it is, but it's below this level. So if this was the true pattern of rise and decay, this was what they saw. They saw no mercury, mercury, no mercury. 2 to 3 days residence time, that's all there is. And soon this dropped down here, but after a rapid rise, rapid decay, then it's a very slow decay after that. Now, fortunately, people have gotten data for us before, and was this recent? No, this was in 1980 by Thomas Clarkson, one of the grandfathers of mercury research. But Clarkson was an environmental researcher, really, environmental toxicology, and so this did not translate into the clinical world because the clinical people were not looking at this literature. So what do we see? These are people eating walleye, and down here is in hours. This is 3 different people. Volunteer A, B, and C. You see a 12-hour peak of this is whole blood. This was nearly a 50-fold rise in the blood. And then a rapid decay, then a slower decay after that. Same pattern for everybody. It depended on their digestion, how fast it was. Boy, look how often they poked these people. That's a tough one. So how long did it take to get down to baseline? Was it 2 to 3 days? Or was it 160 days? So the rapid decay of about 36 hours, and then the slow phase of decay back to baseline of 160 days. These were all healthy graduate student volunteers being tortured here in this. And so you see that this is not 2 to 3 days. It's a long, long period. And when you have even longer chronic accumulations, there's even a slower phase that takes, over a year. Maybe that's just because once your levels get down, the rate of your body's detoxification gets slower. So even once you get down to baseline after 160 days, it still takes longer to really get yourself down. Someone with a real deep detox, if somebody with very high levels, it's going to take at least a year, if not longer, to get to the deepest pools. So now, the most contentious aspect of everything is challenge tests. What do they mean? Are they necessary? I've been speaking with another school that has really laid down quite a bit. People have a lot of stake right now in the challenge test being the thing that's going to differentiate somebody. Well, that's really going to be your test that's going to show you high body burden versus low body burden. And what I'm going to give you as an argument here is that you don't need the challenge test. I think at one time the challenge test was very useful, and it was a good way to screen through a lot of different metals at once, but it does not have the mythological significance that people attach to it. Namely, that it gets into all these compartments and shows you the long-term body burden. And what you see when you look into the literature when people look at challenge tests is that the challenge tests are reflections of what is in the blood and probably a little bit of what is in the kidney as well, because they're going through the kidney and they're pulling a little bit out of the kidney. So this study was done not yesterday, but in 1991. So this data has been out there for a little while. And people were pretty resistant to this paper from what I hear, or at least the challenge test people. But, be that as it may, when you look at the data is very clear here. And this is a very well-defined experiment where they're looking at mobilized mercury during challenge tests in subjects with varying exposure to elemental mercury vapor. What they did is they took groups of people acutely, strongly exposed. These were mercury industrial workers, somewhat akin to the artisanal gold miners now, where they looked at plasma mercury versus urinary mercury. And this is before chelation. The reason they use plasma is because of the way mercury, because of the way it partitions between red blood cells and plasma. Most of the methylmercury, 90 to 95%, is on the red blood cell. Inorganic mercury is distributed 50-50 between the plasma and the red blood cell. So if you look at plasma, it's the first cut at speciation. And so they were able to look at the buildup of inorganic mercury in the plasma as a result of exposure to elemental mercury. And then compare urine versus plasma. And you see this nice, over a broad range, a nice linear correlation. There's some variation, and this is the log scale, so we see some individual variation in the urine-to-blood ratio. But in the big picture, you see a nice linear correlation. And they took acutely exposed workers, very high amounts, but for shorter periods of time, all less than 3 years. Then they took dentists who had been in the practice for 30 years at least. And so this represented long-term, lower level, acute, but subacute compared to these guys, but longer term. Then they took controls with amalgam and controls without amalgam. And as we expect, we see amalgam-free, amalgam, dentists, industrial workers. Then they gave them a 300 milligram DMPS push, followed by 24-hour collection, and then they graphed up plasma before the push and 24-hour DMPS collection. And what do they see? The same linear correlation of what came out in the push compared to what was in the plasma before the push. What they were looking for, the hypothesis was, if the body burden measurement were true, that DMPS was looking at the body burden measurement, you would see the long-term chronically exposed dentist move up and merge with the short-term acutely exposed industrial workers. But in fact, you did not see this. You saw them, if anything, move even farther apart. The amalgam people spread a little bit more into the dental group, and the amalgam-free ones stayed back down here where they were. So you see, what came out in the 24-hour urine was linearly correlated with what was in the plasma before, and it was linearly correlated DMPS urine with urine before. So you see that the DMPS challenge was showing you what was in there already. Now, at times when it was very difficult to get nice measurements on and dissect these ratios between urine and blood and really see what the ambient numbers mean, the challenge test was useful. But the authors go on to say that the mercury excretion provoked by DMPS intake was well associated with pre-DMPS mercury levels in plasma and urine. Our hypothesis was that the body burden and thus the long-term exposure would be reflected by the DMPS mobilization test. However, this hypothesis was not supported by our data. Now, I don't have all the other studies that I've looked at in here. It's kind of an exhaustive thing, and I'm working on a white paper detailing it. But there was another study using DMSA, and incidentally, DMPS and DMSA are very different animals. Even though they look very similar, my experience so far in doing speciation work on urine that has been DMSA challenged is that DMSA is much stronger on methyl mercury than it is on inorganic mercury, and DMPS is stronger on inorganic mercury. When DMSA challenge was given to people who used to be chlor-alkali workers, industrial workers, they compared normal set of people to chlor-alkali people, and they found that they were not able, with the DMSA challenge test, to distinguish between chlor-alkali, ex-chlor-alkali workers who'd been out of the industry for 3 years and people who had never worked in the industry. If the challenge test cannot determine those two groups, then it is not truly looking at body burden. But then also, because DMSA is more of a fish-based thing, that was probably a test of who is eating more tuna fish more than it was a test of who is exposed to more inorganic mercury. Just a look at how these chelators are drawing from the blood, and the blood then is equilibrating with the cells. This is a look at DMSA mobilization of lead in the blood. And this was a look at 10, 20, and 30 milligram per kilogram dosing of DMSA in subjects for 5 days. You see the blood coming down quite a bit. 75% decrease in blood mercury for the high dose and a 25% decrease in blood mercury for the low dose. Then they cease the DMPS addition, and you see the blood levels bounce back up close to where they were before, as these cells then release more of their burden back into the blood. So the chelators draw from the blood, and then the cells restore the blood levels. And this is showing you not only how the mechanism of chelation works, but the importance of very long-term detoxification, because all you really can work from is the blood. And then you need to be able to dump the metals from the blood. So a lot of what we work on is that enzyme system. That's what's responsible for producing it, for getting it to move out of the cells into the blood, and then we want to clean from the blood level. Now, I don't have much, I can't really feed back with people, and if anyone can type in a little note and let me know when you want me to cease this, I'm going to run through a couple of slides. I was hoping to get farther through this, but we can catch up on the next round. So in the speciation testing, this is a patented test that we run that I developed in graduate school. It's the only lab in the world right now where we're doing speciation analysis, so we can separate the fish and amalgam sources, and then we're going to look at different matrices, those being blood, hair, and urine, and compare what's in these different compartments to show excretion or retention of mercury. This is the system that we use. I'm certainly not going to go through it, but it's based on ion chromatographic separation of mercury thiourea complexes coupled to atomic fluorescence detection of mercury. We're able to measure down to 1/3 of a picogram of mercury, and so we're able to see very, very low levels of mercury. This is what it looks like coming out in the chromatogram. You'll see a methyl mercury peak, then an inorganic mercury peak. This is lower, higher, and highest. These are equal amounts put through as standards, and these are what natural amounts look like. As I mentioned before, methyl mercury will be higher than inorganic mercury. This is someone with lowest levels. This is someone with much higher levels here. And this person had very strong amalgam exposure and fish exposure, but this is a classic non-excreter. This person's exposure had stopped quite a long time before this analysis, but it was still very high. And this person had cardiovascular disease very strongly, had heart attacks, heart valve transplants, and cancer several times by the time they were in their 40s. So in our measurement suite, we've got blood, we've got methyl mercury and inorganic mercury, and then in the hair you've got methyl mercury. So we are then going to compare methyl mercury to blood, methyl mercury in the hair to blood methyl mercury to look at excretion of methyl mercury. This ratio here traces back to a Boyd-Haley study where they found that autistic populations had lower matched to non-autistic controls with similar mercury exposures from their mother. They had lower amounts of mercury in their hair, and the more severe the autism, the lower the mercury in the hair. There was a failure to express through the hair compared to the normal populations. Urine is all inorganic mercury. We're now going to compare inorganic mercury in the blood to inorganic mercury in the urine as a measure of how well the kidneys are filtering the inorganic mercury. I'd mentioned the partitioning. We use whole blood, not packed red blood cells. This is because methyl mercury is much more on the red blood cell, somewhere between 90 and 95% on the red blood cell, and inorganic mercury is 50-50 between the RBC and the lymph. Now, interestingly, Klinghardt refers to methyl mercury as an intracellular toxin able to get into the blood, and Hg2 is more of an extracellular toxin. So think about poisoning of the extracellular matrix. System, and lymph is an extension of blood, of plasma, and so there's 5 times more lymph in the body than there is blood volume, and thus you've got and lymph is plasma is what's becoming lymph and what's equilibrating with the extracellular matrix, and so we have a strong ability to poison the extracellular matrix, and the extracellular matrix is really what's responsible for mediating exchange between the cells and the blood. And so if the matrix is poisoned and has become congealed, you're not able to move toxins out and lymph in. So we're looking at both of these forms in whole blood. And just in case you don't know how broad the extracellular matrix is, if you were to strip all the cells out of your body, you would really, if you did it gently enough, the morphology of your body would not change. This is a picture of a rat heart that was treated with a cocktail to get the cells off of it and leave just the matrix. Then they were going to restore the cells with stem cell treatment. And here you see the cells being stripped away. Here's the rat heart with no cells at all, just extracellular matrix. Point number one, here come the stem cells, there comes the heart again. The heart is no different in morphology than it was there. The matrix is a phenomenally large part of the body. Point number two, why could the stem cells suddenly become a heart again? Probably because of the encoding in the information systems of the extracellular matrix. So if you're poisoning that, you are poisoning the whole body. All right. Just to see now the first look at the testing, and I apologize, this is how our testing used to look, where the later tests that we look at, we're going to see what the testing looks like now. But in this patient has good excretion profiles. This was a biological dentist who kept a pretty clean ship, and you see methylmercury. This is the hair to blood ratio. This is the methylmercury level. That's the patient in blue. In gray is the average or the median or the mean number of everybody who've gone through our testing. Here's the inorganic mercury. There's the patient. There's the average. Now this is higher than somebody with amalgams should be, but because she was removing amalgams all the time, you do see a little bit of it there. The hair to blood ratio is good, and you see not bad accumulations of methylmercury. The blood to urine ratio was good, and so as the inorganic mercury is going into the system, you see that it's being moved out of the system. Here is quite a different scenario. The blood methylmercury is 10 times the average. The inorganic mercury is 10 times the average. This is also a biological dentist. This was in the Huggins School. This person kept a clean ship. Why is this person such a mess? You see the hair to blood ratio is very bad, and so there's accumulation of methylmercury. The urine to blood ratio is a complete mess. The kidneys are completely blown out. You see very high accumulation of inorganic mercury, even though they're exposed similarly to other biological dentists. What is the key problem in this person? What was their pathology? They had Crohn's disease, chronic intestinal inflammation. So if you think back to that picture of what inflammation in the gut does, it blocks both roots out and blows out the kidneys. This person was blown out in all the excretion pathways, and everything that went in stuck in there. This is a very difficult case to work on. We've been working on them for years. We're getting them better slowly, but it takes a long, long time to get all of these things down because there's such a downward spiral of inflammation rooted in the intestines. One more example here where methylmercury is not so high, inorganic mercury is. Hair to blood ratio is okay. Urine to blood ratio should be up around here, but it is very depressed, and you see a lot of inorganic mercury build up. This person was actually getting better. Usually for levels this high, I would expect this ratio to be down here, but this person was on the mend. A dentist, all from environmental exposure in the office, must have been much higher before, really had serious symptoms. By the time I met him, he was getting much better. Now he's down, I think he's down here, and he's much more healthy now. But you see that ratio. Here is one more example where you see a bad blood to hair to blood ratio, very high accumulation of methylmercury. This person was a weightlifter, and his naturopath told him that red meat was bad. Now this person does not know the difference between grass-fed beef and corn-fed beef and all the inflammatory cytokines in corn-fed beef, so they thought tuna was good. This is the wrong person. There's the blood-to-hair ratio. This is the wrong person to be feeding tuna all the time. So this person now was now 20-fold over the average and very high, 10-fold over the average for inorganic mercury. With a full detox program and amalgam removal, 80% removal of methylmercury in 6 months and 90% removal in 6 months. Methylmercury for this person is down to 1 ppb from 20 now after a year of detox. But this is typical, 30% after about 2 months, and then you really see the decreases happening over 6 to 9 months. Now this is how our testing looks now. You've got separate reference ranges for methylmercury and inorganic mercury, where the methylmercury, if you look at the 95th percentile, now is 7.4 parts per billion. The 95th percentile of inorganic mercury is 0.47. So you see this very different expression of the two in the blood. Here's a situation. These are switched now. Urine to blood ratio over here is not too bad. That is a level I would expect from high methylmercury. Some of that's breaking down to inorganic mercury, and the rest is coming from amalgam exposure. The inorganic mercury is about the 70th percentile, whereas the methylmercury is close to the 95th percentile, and you see bad hair to blood ratios here. So you see accumulation in the hair in the methylmercury compartment. So even though amalgam is part of the problem, the fish-based stuff is where the real problem is. Here you see high inorganic mercury. Not so bad on the methylmercury, though I'd want both of these down in a detox scenario. And you see urine to blood ratio is showing a problem, and the hair to blood ratio is not. Now, once you get good at reading these tests, you'll be able to distinguish small variations. Like looking at this inorganic mercury level, I would expect this ratio to be even more strongly depressed. The fact that it's only a little bit off the line tells me that not only is the kidney poorly functioning, but not radically poorly functioning. That means that the exposure is high from the amalgams. It means there's a lot of amalgams, or the amalgams are bleeding very strongly. Maybe there's gold and mercury right next to each other. Maybe you've got a galvanic situation. Maybe the amalgams were made poorly and they're off-gassing very strongly. So here we see the inorganic mercury being the strongest problem. Here is a test where both of these are coming back bad. We had to change the scale here just to get this on the scale, and the methylmercury is way over the 95th percentile. The inorganic is over the 95th percentile. This individual was from Hawaii. He was a welder, ate a lot of ahi tuna, thought he was helping him things, but he's exposed to vapor phase metals as well as significant amounts of methylmercury, and had a mouthful of amalgams. This guy was really a mess. You see the urine to blood ratios are bad. The hair to blood ratios are bad. Detoxing this person is going to take a long time. When we get into talking about the detoxification, we're going to talk about pre-tox protocols, what you do to get the person ready before you jump into things like IMD that are going to move the mercury out of the body. And the practitioner here did jump too quickly into the detox, really shocked the person. I mean, they came back from it very easily, but you know, they felt so terrible during the initial aspect of the detox, they were afraid to go on with it. So we'll talk about how to organize your pre-tox protocol based on these measurements, how to support the different organ pathways before you get into the major detox and during the major detox. So you see problems in both ratios, problems in both pathways. And just to show you frequency of the population, the hair to blood ratio, you see this normal this normal population histogram. Then you see, so this is on the good side of those plots. This is good ratios, bad ratios. Then you see this bump out here with really bad ratios. And this looks similar to the bump we saw, the genetically ill-equipped group out on the outside. When we start doing genetic testing along with our profiles, we'll see if this is that group that we're talking about, that this is a genetically separate group. When we look at the histogram of the blood-urine ratios, these are good ratios, these are bad ratios. We see what I believe is not just a normal population group, it's a normal population grouping with a big long tail on the end. That's progressive dysfunction of the kidney filtering systems. Just a problem, you probably are savvy enough to know that my testing is not going to tell you what the toxic response is. It's just going to tell you what the body is exposed to and how it's fielding those toxic responses and how it's starting to get rid of them. So levels cannot show you how toxic the person is. The toxic response is a combination of the abilities of your defense system. That is what that big, how strong that big reservoir of sulfhydryl groups in the cell is, how much it's going to protect you from that mercury hitting sensitive sites on enzymes, hitting the sensitive areas of the mitochondria of all of the different enzymes, and really creating the toxic effect. And then there's hypersensitivities or allergies that are developed, and these can be type 4 delayed hypersensitivities, such as shown in Melisa. Whenever anybody shows with a Melisa positive, they're going to be extremely toxic at the same level compared to someone who doesn't have one. However, there's a whole string of different hypersensitivities that will show up with ART testing, but will not show up with a Melisa type testing. So there are other hypersensitivities that we don't have labs for yet. So toxicity has to be diagnosed from a combination of your clinical diagnosis, looking at the symptomology, looking at the symptom questionnaires, where are these symptoms showing up, and auxiliary testing. And the auxiliary testing can be Melisa or ELISA testing. Of these two, for metals, I find Melisa more sensitive. It could be porphyrin screening, looking at stresses in the ATP cycles. It can be glutathione system, glutathione markers to see what your antioxidant system looks like. We're starting to develop a panel that'll show glutathione enzyme activities. This is really more important than glutathione, but nobody's measuring it. Then when we look at thyrodoxin is a very important super enzyme, super protein in the antioxidant system. We want to put together a panel of all of these so we can really see what that super system is expressing like and what that reservoir for protection is looking like. And then there's gene testings to look at glutathione formation, glutathione as transferase expression. ApoE has been shown to be a good predictor of sensitivity, and CPOX. Of these, GST and ApoE are the only ones you can get commercially now. We're working now on getting the MRP2 genes added into this and get a nice commercial panel that can be offered. So that's the end of that. When we go into next week, we're going to start talking about how we work on the detoxification system. And so if there's any questions, if anybody has any way to get their questions to me, I will field them now and end up with that. So next time, hopefully you can get the conference phone, your Spider there, hooked into the telephone system so that we can have a little more feedback. And Dr. Gant, I know your headset was active, so if you have any question.
Yeah, he just left. I think he had another appointment. Dr. McClure says thank you, and he will call you later.
Okay, very good.
And so I think we're just a couple minutes over here, so we'll just end it for today and continue in 2 weeks.
Okay, very good. Thank you very much.